Let me introduce you to the newest member of the QAR family, the QAR50. The QAR50 is meant for production testing of automotive radome samples. We have used our experience to slightly enhance the QAR50 for this purpose. The instrument consists of two clusters. One measurement cluster is up here and another measurement cluster is down there. So with these two clusters, we can measure the transmission loss, we can measure the reflection and also the transmission phase. We can measure all these results frequency resolved. Another enhancement of the QAR50 is its self-calibrating capability. Therefore, we are using two spherical reflectors. One spherical reflector is positioned up there, and the second one is positioned down there. Same as for the QAR, for the QAR50, we also have the verification plates. Those plates are accurately measured in both reflection and transmission loss and can be used to verify the correct measurement result of the QAR50. For this demonstration, let us use a slightly more exciting sample. Here you can see an automotive bumper sample. The bumper has some structure on the inside and also has some curvature. So the reflection of this part is very challenging to measure with standard T&M equipment. Let us have a brief look at the measurement result of the QAR50 here. So what we see on this screen is the measurement result of the reflection of cluster number 1. Cluster number 1 is the upper cluster in the instrument. So on this page here, you can see the reflection result of cluster number 1 in frequency band number 1, which we have defined as 76 to 77 GHz, and frequency band 2 as 76 to 81 GHz. You can see the square here on the measurement result. The square that you can see here is the measurement area that we have defined. Within this measurement area, the QAR50 depicts the actual measurement volume itself. So therefore, you can see this black line here. This black line depicts the 3 dB zone around the point of the highest reflection. With this measurement method, we can accurately measure both the reflection and the transmission of the sample. As promised, we have the reflection from both sides. So now you are seeing the reflection from cluster number 2, and you are also seeing the influence of the curvature of the bumper. This reflection is available for both frequency bands, same as for the attenuation that we see here. So again, frequency band number 1 was defined as 76 to 77 GHz, and frequency band 2 was defined as 76 to 81 GHz. You can define those frequency bands yourself in the settings if you require other frequencies for the measurement. We are also measuring the transmission phase in these two frequency bands. The transmission phase can be used to measure and to test for the homogeneity of the radome sample or the bumper sample. Also, the transmission phase is available in both frequency bands. The transmission phase is highly correlated with the reflection. Therefore, we also have a high-definition image of the reflection. So here you can as well see the structure of this bumper. We also have the high-resolution image of the other side of this bumper, which in this case has no structure and another curvature. We also have the frequency resolution. So here you can see the frequency response of the bumper from 76 to 81 GHz. You can also see the reflection frequency response of the bumper, in this case also from 76 to 81 GHz. The QAR50 can easily be customized using software licenses. Therefore, the instrument is the ideal tool for production measurement. If you have any further question on the instrument or its measurement methods, don't hesitate to contact the local Rohde and Schwarz sales force. Thanks for your attention.